Hello students, this is Dr. Faizan Mirza. I'm covering with you the topic of diversity index here, in which is basically used to compare like for like comparisons of two sites which are similar. For example, two shores. You compare the diversity of one shore with that of the other. You compare the diversity of one pond with the other. Or you compare the diversity of, for example, one rainforest with another rainforest. You never compare two unlike things. You cannot compare a shore with a desert or a lake with, for example, a tropical rainforest. So you calculate Simpson's diversity index or Simpson index of diversity. It is denoted by the capital letter D. The formula is D is equals to 1 minus sum of n upon capital N whole bracket squared. The value of this will always come out to be between 0 and 1. The value will be taken to 3 decimal places. This worked example here shows to you that on a rocky shore, the number of individuals counted on shore A and shore B are mentioned. You can see, for example, this is the catalog or list of all the species present. Every value which is given under shore A is the small n or the number of individuals present at that shore. For example, painted topshell are 24 on shore A and 51 on shore B. Limpets are 367 on shore A, 125 on shore B, and so on and so forth. If I add all the values of shore A, I get my capital N, 1107. This value is the total number of individuals present on shore A that have been counted. Similarly, capital N for shore B is 861. How can you calculate the Simpson index of diversity? You just make a table. The table will be provided to you. You can see the same organisms have been mentioned again. The total n value is 1107. You mention the small n values. You make two different columns. This column is n upon capital N and then n upon capital N whole bracket squared. How do you do this? So you just take 24 and you divide it by 1107. Because it is n, small n divided by capital N. Small n is 24, capital N is 1107. The answer is 0.022. You place the answer with 3 decimal places. It means that the last value need to be rounded off depending on the fourth value here. Then you square this. The square of this value is mentioned in the next column. Similarly, the next value is 367. How do we arrive at these two values? We just use, again, 1107. So we use 367 divided by 1107. We get the value here. Again to 3 decimal places, and we square it again to the 3 decimal places and place it here. So we fill out the last column and this column as well. The last column that we have filled out is n upon capital N whole bracket squared. This is the value that we'll add up. So that will give us sum of n upon capital N whole bracket squared. In this case, it's 0.201. So we get a value of the sum of this value. If you go back to the formula was diversity index can be calculated when 1 is there and you subtract this value from 1. So when you are taking the sum of n upon whole bracket and n upon capital N whole bracket squared, so what will we do? The value is 0.201. This value will be subtracted from 1. So this is 1 minus 0.201. The answer comes out to be 0.799. In this case, the value is actually telling you that it's closer to 1, which means that the diversity of shore A is high. The same thing can be done for shore B. The values are given. I have mentioned all these values here. The small n values are mentioned. The capital N value can be calculated by adding these, which in this case will be 861 because this is already mentioned in the table on the previous page. So you calculate this here. All the values are given except for a few which I have missed from here. You can just calculate this value and the sum of the last column. You'll place the answer here. You'll subtract this from 1. You will get the answer for diversity index. The diversity index will always be to 3 decimal places. You will just compare how close is to 1 or how close is to 0. So if you just work on this example, you can calculate the diversity index of shore B. And the answer that you will get for shore B, you can compare it with shore A. Shore A is 0.799. We know it's highly diverse because it's close to 1. The answer of shore B will also be telling you whether it's high diverse or it's low diverse, depending on whether it's close to 1 or it's close to 0. And then you can just compare the two shores together. The one which will be having a value much more closer to 1 will be more diverse. And the one that's having a value closer to 1 but lesser than the previous one will be less diverse as compared to the other. Then you can look at the table and you can look for the reasons why one is more diverse than the other. That's it from my side. Thank you so much.